Did you know that Pluto isn't the only dwarf planet in our solar system? Besides Pluto, there are 4 other dwarf planets in the galaxy: Haumea, Moki, Ares, and Ceres. Ceres is the smallest of them all, and yet the celestial body was once considered a full planet. But that was long before it was discovered how small Ceres actually is. Ceres has an equatorial diameter of just under 600 m and is thus much smaller than the Earth's moon with its more than 2,156 miles. Ceres's actual size could only be determined a few years ago with the help of the Hubble telescope and the Dawn space probe. Previously, astronomers assumed its diameter was between 373 and 621 miles. The dwarf planet is part of the asteroid belt moving between Mars and Jupiter. By the way, the rocks of the belt are by no means small. The diameter of an asteroid can be a few miles. Ceres would not be a dwarf planet, however, if it did not stand out from this immense collection of celestial bodies. It is the largest object in the asteroid belt, the discovery of Ceres. While real planets have such a size that they can be seen with a simple telescope, minor planets remained undiscovered for a very long time. Ceres, too, could only be hypothesized before its discovery. In 1770, the physicist and astronomer Johann Kepler was the first to express the statement that a small planet might circle between Mars and Jupiter. He could not discover it, but calculations confirmed the assumption, and he made it a task of science to find the small celestial body. Various observatories searched the sky for Ceres from 1800 on, until the dwarf planet was finally discovered on January 1st, 1801. Its discoverer Piazzi, however, at first thought Ceres was only a comet. The famous mathematician Carl Friedrich Gauss also succeeded in sighting the planet a short time later. For almost 50 years, Ceres therefore was considered a full planet before it lost this title and was then called a minor planet. Since its discoverer was from Sicily, Ceres was christened after the Roman deity of agriculture and protector of the island of Sicily. Incidentally, a few years later, cerium, a chemical element, was discovered, which in turn was named after the dwarf planet, the Dawn probe. In 2001, NASA decided to launch various projects that would shed light on the early history of the universe. One of these projects was named Dawn, which in other words means twilight and thus an appropriate name. In 2005, planning began for the Dawn mission, first set to further explore the dwarf planet and the asteroid Vesta. After various delays and a threatened abort, the probe was ultimately built, named Dawn, and launched about 2 years later. On September 27, 2007, the spacecraft began its journey to the dwarf planet and asteroid Vesta. The mission lasted 11 years and brought amazing findings to light. The journey to the probe's destination took nearly 4 years. On its way, Dawn circled Mars in a swing-by maneuver to gain the momentum needed to continue its journey. Then in 2011, Dawn took its first out-of-focus image of Vesta. At just under 323 miles in diameter, the asteroid is more than half the size of Ceres, but is still not considered a dwarf planet. A short time later, Dawn was brought into orbit around the asteroid. From there, better images of Vesta were also obtained, and initial insights into its procurement and composition were achieved through these photos. Some mishaps led to the fact that the Vesta mission had to be extended. It was not until September 2012 that the journey continued to the actual destination, the dwarf planet Ceres. The first priority was to fully map the celestial body. During the imaging of Ceres, measurements were also made to determine the chemistry of the soil. During this time, the Dawn spacecraft was at an altitude of just 236 miles. To expand the mapping effort, its orbit was moved to an altitude of more than 870 miles about a year later. But that was by no means the end of the story. To complete the mapping, Dawn was flown another time to an altitude of over 4,350 miles. From there, data was confirmed and partially recalculated. The spacecraft achieved its highest altitude in orbit in February 2017 at a distance of 12,427 miles from Ceres' surface. Actually, the mission was meant to continue on to study the asteroid 145 at Iona. However, due to the numerous breakdowns and failures of its reaction wheels, it was decided the mission should end. Dawn was then lowered to a distance of only 31 miles above Ceres' surface. On June 21, 2018, it was powered down. Since then, the spacecraft has continued to orbit Ceres. Thus, the dwarf planet now has a satellite until the end of time. The surface and other facts. The images and measurements taken by the Dawn spacecraft provided us with numerous insights into the dwarf planet, things relatively unknown until a few years ago. Without the mission and numerous orbits of the celestial body by the probe, astronomers would have been left making guesses at best, and the actual origins of Ceres would have remained a mystery forever. Through the differentiated mapping, a surface area of 1,770,98 square miles could be calculated. That's an area into which all of Germany would fit approximately 8 times. But what does the surface actually consist of? Measurements have found that the entire surface of Ceres must be equally dusted with powdery regolith. A day on Ceres lasts 9 hours, 4 minutes, and 27 seconds. It takes 1,682 days to orbit the Sun. 1 year on the dwarf planet thus takes 4.5 Earth years. The gravity on Ceres can hardly be described as such, with 0.289 and 289 feet per second squared. The gravity on the dwarf planet is just 136th that of the Earth. This means that a human weighing about 160 pounds on Earth would weigh just under 5 pounds on Ceres. The dwarf planet is more than 257 million miles away from the Sun, and has, among other things, an average temperature of just minus 159 degrees Fahrenheit. So not exactly pleasant, because the asteroid Vesta was an important part of the mission. The two celestial bodies could be directly compared. Ceres is not only about twice as large, but also has 3.5 times the mass. Together, the two celestial bodies account for a quarter of the total mass of the asteroid belt. Incidentally, Ceres is also the only dwarf planet in our solar system that has no moons. All other dwarf planets have at least one moon. Even Pluto has 5 satellites to itself. Is there water on Ceres? Because the density of the surface is incredibly low, a layer of water ice over 300 feet deep is thought to exist between the sediment. Ceres is actually too far from the Sun for liquid water. But this is not completely ruled out, and that in turn would mean that simple life forms could exist on the dwarf planet. What the composition of the atmosphere on Ceres is not clear at the moment, but the layer of water ice could lead to an atmospheric composition consisting mostly of water vapor. Evidence for this was provided by the Hubble Space Telescope with unique images. After initial doubts, it became clear the observed escaping water vapor had the dwarf planet as its origin. The water layer under the surface is probably transported to the surface by heat generation in the interior of the celestial body. The water vapor then reaches into space and evaporates. Calculations conclude that in a second up to 13 pounds of water evaporates there. The composition of the dwarf planet. In recent years, the Hubble Space Telescope has provided further information about the composition of Ceres. It is assumed that there is a solid core of rock inside. This rocky core is enveloped by a mantle. The upper layers of Ceres consist of minerals and water ice. Although Ceres has so many characteristics of a planet, it never became and never will become a full-fledged planet. Astronomers suspect that Jupiter prevented the full growth of this dwarf planet. This happened due to the high attraction exerted by the planetary gas giant. After all, Jupiter is the largest planet in our solar system, so Ceres had no chance at all to attract enough mass to grow to the corresponding size of a real planet. This period of growth happened about 4.5 billion years ago, but halfway through its development into a planet suddenly stopped. This is why Ceres is so interesting for science, because the dwarf planet shows the intermediate step in growth that other planets must also have undergone. Forever frozen in time, the unfinished planet Ceres, a dwarf among planets, a goddess among asteroids. Through space telescopes, and especially through the mission of the Dawn probe, many mysteries have been solved. But just as many questions have been raised since and remain to be solved. What do you think? Should the dwarf planet be explored further? And can the exploration of Ceres perhaps still answer some questions we have on the relationship between the formation of the universe and the planets? What facts and findings surprise you the most? Write down your comments below.